So hopefully, I finished writing a little assessment that we're going to have next week. What day is it next week? Since we don't have class on Monday, it must be Wednesday. Okay? My Tuesday, Thursday class is probably going to have it on Tuesday. So if you know people in that class, talk to them. Okay, it's called being smart. So what is the job of the frontal lobe? No, that's the prefrontal cortex. The prefrontal cortex is the planning part of the frontal lobe. What does the frontal lobe do? Behavior. It produces behavior. This is one of my favorite behaviors that I spend a lot of time doing, probably too much. This is not a very good yo-yo, so it's a little dangerous. But so in order to play with the yo-yo, what do you have to do? Okay, this one's not a very good yo-yo. It's a pretty cheap yo-yo. Okay, but I have a good one in my car, but it's the one I keep in my car. Because you got to have a yo-yo in your car, because you can't do without a yo-yo. I mean, seriously. Nerds. Okay. Yeah. Okay. So when in order to play with the yo-yo, what do you have to do? Very cranky. Oh, Gary. Okay, what do you have to do? Don't say practice, because practice isn't something that you do. Define practice. You're not saying the words. So whenever we study anything in psychology, you have to measure behavior. Woo! Practice. Practice doesn't exist. What exists? Behavior. So you repeat the same behavior over and over again. That is practice. Repetitive behavior. Taking your cognitive self, putting it away, putting it into behavioral psych terms. Okay, so this is the reason why I actually have this yo-yo. It's a terrible as far as yo-yos go, but it's meant actually to be what's called an off-string yo-yo. Okay? So this is always fun in this classroom because it's the only place that's really big enough for me to practice that's got carpeting. Because me practicing this in the living room is dangerous. Now that we actually have a real-size TV, it's even scarier. So what is it? Oh, it's very dangerous. Getting it to wind back up is always tricky. Okay. Oh, quit using the mind. Doesn't exist. Sorry, I'm being mean. Okay. I had a big jug of green tea, so I'm like seriously caffeinated, deprived, and extremely have to pee. Moving on. Okay. I love green tea. Don't say that now because I might let down. It's not good. Okay. So what happens is I need to coordinate two things together to do this. What are the two things that I need to coordinate? Okay, I need to figure out where the yo-yo is going to be before it gets there. So I have to use my prefrontal cortex to plan. What am I using to plan? Say it louder. Your eyes. Whoever said that? There it is. Okay. So you use your eyes to plan it. So what I'm doing is I'm taking information from my occipital lobe back here. My occipital lobe back here sees the world around me. Then the information gets pushed forward into my prefrontal cortex. My prefrontal cortex says, aha, the yo-yo is drifting off to the left a little bit. So what do I have to do? So when you throw it up, oh no, not in the parking lot. It has done that before. For some reason, the off-string yo-yos break significantly faster than regular yo-yos. Not sure why. Okay. They're usually made out of some sort of rubber. When I ordered this one on Amazon, I didn't realize that this is a cheap Dunkin' one. Dunkin' bought a good company called Yo-Yo Jam. Okay? Yo-Yo Jam makes excellent yo-yos, just in case. Well, they used to. Now Dunkin' makes Yo-Yo Jam. So if you buy the really high-end one, they're still very nice. The boutique brand. You don't care. Moving on. So this was supposed to be made out of rubber. So you can like kick it and bounce it and do all sorts of cool things. This one's made out of hard plastic. So what's going to happen to it after it hits the ground 5 to 10 times? It's going to crack. It's got a little crack on the edge already. It kind of catches my finger when it's really annoying. Okay, sorry. So what I have to do is I have to throw it up in the air and then catch it on the string. If I throw it correctly first, is it easier to catch? Yes. Okay, so what do I have to practice? You have to practice throwing it first before you practice catching it. Because if you activate the right sequence of motor program, what's a motor program? Okay, so as a shot putter, you have motor program. Okay, the motor program is someone, if you say to throw a shot put, you don't just go, nah, more than once. This morning we were doing medicine ball throws. And so it's so fun. We have these big slam ball medicine balls. They're like big and squishy. So you take one and I always hold it like this and I throw it up and then I catch it and then you catch it and you throw it up and you catch it. It's so fun. And I'm like laughing the whole time. I'm like you're really not smart. Because why is it fun? I'm throwing heavy things. What could get better than throwing heavy things? Okay. And everybody else just thinks I'm a moron, but whatever. Okay, so what happens is when you activate a motor program, if I want to throw something with one hand, I know put this hand out. I know hold it here. Why not hold it out here? Balance. If it's near your body, you can balance it. And I dip with one side so I can throw it better. And even though my shoulder hurts today, I was able to throw it just as high with my left hand as my right hand. Because, what do you think? Do you think it's the same motor program twice? Is this the same motor program as this? Yes. Same motor program. What changes? Left versus right side. So I'm going to assign this side of the class right here. You are that what side you're, that's the left side. You guys are officially the left side of the brain. You guys are right in there. Okay, we'll have to, I don't know what each side of the brain. Okay, so this is the left side of the brain. This is the right side of the brain. What hand does this side of the brain control? The right side. Everything that is on the left side, controls the right side of your hand and your foot. Brace yourself. And it sees the right side of the world. The left hemisphere sees the right side of the world. So if you guys look directly at the board, okay, the two folks that are sitting in the middle, you see the board with both eyes. But if you guys stare straight ahead, you're not looking off to the side. When you're seeing things that are over here past your nose, you're only seeing things on the what side of your brain? Left side of your brain. If you guys are looking straight ahead, and I go way over here, if you see stuff over here, you're only seeing things on which side? The right side of your brain. Now there's a huge bundle of fibers that go back and forth across. So do you notice that you have two separate left and right sides in your brain? Do you notice? No. Because they do almost the same thing at the same time. It's really interesting though, your left hand, that's my right hand. My right hand, dyslexia sucks by the way. Anyway, your right hand is controlled by your left side. Your left brain controls your right side. I just said the same thing twice. That's brilliant. Okay, I'll get this figured out. One of these days. I've been teaching this for a few years. So, do you have two separate selves then? Where's your self? In your, say it louder, parietal. Okay, in your parietal lobe. You have a sensory cortex. The sensory cortex on your left side of your brain feels exactly the right side of your body. It's super creepy. Has anybody known someone who's had a stroke or a Bell's palsy in here? So when someone has a Bell's palsy, what happens is the nerve, the trigeminal nerve that controls the movements of their face, stops working. Yeah, and their whole side of their face stops. And there's a spot in the middle of their lip where one part works and right next to it the other part doesn't work. It's crazy. But what it is, it's the same thing as our neighbor had a massive stroke. And we used a Sharpie. I mean, this is not being mean, but use a Sharpie. Okay, can you feel this? Can you feel this? Can you feel this? And as soon as she said no, we changed color of the Sharpie. So we started this side with the red one and this side with the black one. And what we did is there was a line down the middle of her forehead where 1 millimeter one way was red. She can't feel it. The other side, 1 millimeter away, was black. She could feel it because she got damage in her parietal lobe because of a stroke. It's so freaking weird. Why would you only feel one side of your body and one side of your brain? What if you had all your body stored in one place? All of your body stored in one place. What if it got damaged? Someone hit you on the head with a rock, or you play football. What happens? You lose everything. What's even weirder, and it really starts becoming more complicated when you start understanding motor programs. What becomes weirder is if I pick up something with my right hand, which leg do I balance on? Your left leg. This part of your left leg all the way up to your trunk is controlled by the left hemisphere. So when I reach to grab something, these muscles and my leg muscles are activated by the same part of my brain that reaches out and grabs something. So it's not exactly opposite. Your hands and your feet are opposite. Your face is opposite. But your legs, your butt, and your core are same side. I know. That's why it's so important when you do exercises that's why I believe a lot of one-handed exercises are important, because what do you work on? Well, you're not working on, if I pick up something on this side, I'm strengthening this side of my body. If I pick up something on this side, I'm strengthening this side of my body and these muscles, which makes you balanced. Balance is healthy. Not much more. Okay, sorry. Now, I like yoga, I just can't wear the pants. Okay. No one needs to see that. That's not good. Okay. So, the occipital lobe, back here, is where you see things. You see things in the occipital lobe. So, what you see, do you see a left side of the world and a right side of the world? Yes. Yes. But most people, when they want to look at something, what do? Do they look away from it and see it out of the corner of their eye? Obnoxious. Let me look at you. They don't look at you like this. How do they look at you? They stare straight at you. Because when you're staring straight at something, guess what happens with your brain? No, it actually goes to both sides equally. So when you stare at something, it goes to both sides equally. And our brains are actually evolved to figure out how to focus your eyeballs on things. You ever notice? So look up at the top of this, look at the speakers up there, and then slowly move your eyes all the way across to the speakers on the other side. How do you move your eyes? Chunk, 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 chunk. So your brain takes snapshots. Clunk. Here's the world. Whoosh. Occipital lobe sees the world. Your eyes move. You know, unless you're really stoned, do you notice your eyes moving? No. Thank you. Okay, so they're not moving. Okay, but the reason why I say that is there are some people with what's called ocular tracking disorder. Ocular tracking disorder, that's what vision therapy can really actually help, is where your eyes don't focus where they need to focus. So when you go to look at something, your eyes go zigzag, 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 zigzag. What happens with your ability to see things if your eyes are zigzagging, zigzagging? It gets blurry and you get headaches trying to hold your eyes still. My daughter had a problem when she was little. One of her eyes would go, yoink. Lazy eye? No. She learned to hit a tennis ball. Yeah. So that's usually there's what we call repetitive motor behavior. A lot of times there could be tics. Usually it's a sign of anxiety. And so when my friend's son was having a really hard time, and he went to a new middle school, elementary school all the way to urban discovery, and all of a sudden public middle school. And so it's just a major change. And he started going, like, that clearing your ear pop thing. The sad thing is it contagious for the rest of us? Yeah, if I just did that in the motion in my mouth, some of you like, stupid mirror neurons in the parietal lobe. Okay, but what happens is sometimes you get stuck on it's called a repetitive motor behavior. Yeah, and so we call our tics. But sometimes those tics are caused by, there's a part of the brain we're not going to talk about called the basal ganglia. That causes tics. I can show you what it looks like. I have to pause this word again. So the part of Jess Tom's brain that suppresses motor programs. Once you learn a behavior and you've practiced it, that motor program's ready to go. So think about all the behaviors that you know. Everything that you know, they're all ready to go right now. All I have to do is activate the behavior. So my prefrontal cortex doesn't have to go, okay, muscles contract, fix this, go this. So if I want to say the word onomatopoeic, don't use it very often, it means, I don't remember what it means. Anyway, word that sounds like what it says, like splat or splow. Okay, nice. So if I say the word onomatopoeic, I haven't said that word probably in 2 or 3 years. But how do I know how to say the word? Because I've said it before, the muscles in my mouth know how to form the sequence of muscle twitches to say a complicated word. Okay? And so by knowing how to say it, all I have to do is say, hey, basal ganglia, release the onomatopoeia. Okay? And then so all of a sudden it just goes, and splats out. If you see someone who has impulse control problems, a lot of children, anybody work with kids in here? Impulse control. One kid will be irritating another kid, he goes, rah, and tackles him. You learn how to not, as you get older, you learn not to do that. You just suppress it and give them dirty looks. That's the little child in you going, rah, clank. Like one kid's eating it's my wife's school, kid's eating a box of milk or something, just sipping on it. Another kid looks over and goes, whack, and smacks it out of his hand and goes flying across the lunchroom. Why did you do that? And the kid goes, I don't know, I thought it would be funny. Because it's funny to smack something out of someone's hand. Ha ha! Do you think about the consequences of a box of milk flying across the lunchroom? Worse, Sandy Unified has these bags of milk. Who thought that up? Oh, let me have some milk. Mostly milk. If you're a Simpsons fan, milk, fortified with vitamin R. Oh, one of my bones have been so brittle lately. You're not a Simpsons fan? Moving on. Okay, so she can't control what she says. And she does this periodically. Because those are all behavioral motor programs that we all have. But they're not normally activated, but for her, she can't suppress them. It's kind of like a sneeze. The basal ganglia loves sneezing. And your basal ganglia learns how to sneeze. I am always an odd number sneezer. Always. Boom! 1. Done. Yeah. Okay, so without going into too much detail, because we have a lovely graphically drawn, it wraps around the center of the brain, which we're going to talk about in a minute. So there's 4 parts, the caudate, putamen, globus pallidus, and, oh geez, I'm not taking my physio class in my head right now, so I don't remember the last part. Cingulate gyrus. Oh, sorry, that took so long. Okay, so I'm doing that tomorrow, my physio class. I should know that. So those 4 parts surround the center of your brain. So they're like the workmen that are going on underneath the surface. We're mostly talking about the conscious surface part here. So literally, when you see someone who has, like, so you see a repetitive motor behavior. You see somebody doing something that's different than normal, different than leg twitchy. Most people are leg twitchy. Okay? What you see is that their basal ganglia can't suppress that repetitive movement. And so So you can ask the person, wow, you seem to be feeling really anxious. Can we talk about your parents? And then you get, no, don't do that. That's just, not until you have like another degree or two. Okay. So, but again, when you see behaviors, if you see somebody stumbling as they're walking, what causes you to stumble as you walk? Why do you have to watch out for that third step? Your occipital lobe is constantly changing the motor programs. And when you go off into other space inside your head and stop paying attention to what you're looking at, like my daughter this morning, she's driving to school and she like cuts a corner driving around in our neighborhood. There's a corner around, there's cars parked on either side. She kind of just is on the right side of the road, and drifts over to the left side to go around the corner. I'm like, you can't drive in the other lane. And she goes, why not? So if a car is coming around the corner that we can't see, what's going to happen? We're going to have a head-on collision. And I'm like, you might want to move over to the right. I am. How come she doesn't understand? Why does she have these kind of, she argues back? She can't plan further in the future than a few seconds in front of her car. She can't think about all the possible things that could happen. So like when you're driving on the freeway, your prefrontal cortex is, well, it should be, analyzing all the different cars around you and watching what they're doing, including the cars behind you. If you actually have a good prefrontal cortex, you'll never get a speeding ticket, even if you speed, because you pay attention. If you're passing a police officer, you're a moron. If they're only going 50, pass them. Okay? Because sometimes they'll drive slow so that people that are going super fast will go super fast by them. And then if you're going super fast and they're driving slow, they don't have time. The person going super fast doesn't have time to see them. That's why one of the ways you get people driving super fast is you wait for them to pass you. You just drive in the slow lane at like 60, and the guys go zing by, going, flipping everybody off, and then pull over. And us old ladies that drive, speed limit, in my van. And it's actually looking quite good right now. It's got the roof rack and the cargo rack on the back. Ready to roll. Chains in the back already. Okay, so now. So again, so when your occipital lobe is activating the premotor cortex, the motor cortex is then, wait, are you even conscious of walking? No, it's all unconscious. And that's why your basal ganglia is for. When there's something that you need to step over, your basal ganglia pays attention to it. Has any of you ever taken the phantom last step at the top of the staircase because you're not paying attention? That's your basal ganglia going, I got this. Lift your leg up. My worst one is the phantom last step at the bottom, where you think you're done, you take a step off, and then there's that moment of free fall, where your basal ganglia goes, no, and it causes panic. So what's a way to prevent falling down? Paying attention. Whatever, put your damn phone away. Okay, so my daughter runs into stuff with her phone. Yeah. So restless leg syndrome is lower in the brain. We're going to get to lower in the brain, because restless leg syndrome isn't a motor program, it's just subtle movement. And if anybody has that, it's so irritating. It feels like your leg is cramping up and stuck, and it's just this, I gotta move. Yeah, and it's different than, it's like the muscle feels like it's slowly tightening up, and it feels like tense, and when you stretch it, it feels good. But then as soon as you stop moving it, it feels slowly tightening up again. Yeah, it's really irritating. Like, yeah. No, it's weird. No, it's kidding. Yeah. No, but the bouncing your leg around, that's actually it's just kind of fun, and it's just kind of a habit. It's not really a restless leg. Restless leg happens a lot when you're sleeping, and it really is a major cause of sleep problems for people with real restless leg syndrome, because if you're trying to go to sleep, you try to lay still, and what do your legs start to do? They have to move, and then and if you're sleeping next to somebody, they're like, right now I'm going to rip your ears off. Sorry. Okay. Luckily, I snore, but I don't restless leg. My wife is a very good twitcher when she's falling asleep. Clunk, clunk. Like, okay, stop it. I actually woke myself up doing that last night. Just, okay, I'm sleeping. Good. Okay. Making sure that I'm going to sleep, so I'll shake violently and wake myself up. Anybody know what that's caused by? No, that's an old myth. It's what happens is as you suppress your brain, as I send signals to your brain to shut it down, sometimes the motor program will activate. But it's not a full motor program, it's just a twitch. Because what does the motor cortex send out? Twitches. So you actually activate like your abs, you activate your core. Usually it's your core, your big muscles. And that's why you just, yeah. And it's fun once you realize what it is, because it kind of feels good, but kind of feels awkward at the same time. I like it. Kind of like my life. Okay, so stuttering's another one that's really hard to figure out, because that involves language. Where's language? That was a good segue, thank you. So there's a couple theories on stuttering. My daughter was a very heavy stutterer. She did voice therapy for 4 years before she became bumpy free. My son started stuttering, and we took him in, and they said, it's developmental, it'll go away, no therapy, his is perfectly fine. One of my son's little buddies, Tanner, stutters still. My buddy Nick, you remind me a lot of Nick, because he's tall and doesn't have any hair. But he stuttered, and he actually took debate in high school, because why would you take public speaking if you stutter? He's the kind of guy that if he hurts himself, he works through it to fix it. You know, like, oh, I pulled my quad, I'm going to do a bunch of squats. Well, so he had a bad stutter, so he took public speaking. Because it's funny, when you get into public speaking mode, what happens to your stutter? Meet the parents, or parental guidance. Yeah. Yes, same thing. Trying to teach him not to stutter. Yeah, I haven't watched that, but I've heard that's a really good movie. Yeah, I get really bored at good movies though. I really want to see Spider-Man, Legacy Spider-Man. That's the level of the movies that I enjoy. Not too much violence though. I think makes me nervous. Yeah. Yeah. Well, okay. So escalators that are broken are really sketchy to walk up. Okay. No, I'm serious. My daughter has a scar on her knee because of Macy's escalator that was broken. Okay. She fell at the top because escalator stairs aren't the same spacing. And somebody once figured out the optimal stair spacing for humans. And so if you build a building to a certain building code, there's a certain steepness that the stairs have to be ideal stairness. An escalator is less steep than a typical staircase. And so the stairs are slightly longer than a typical staircase. So if you have gone up that broken escalator like 4 times, it won't feel weird. Because what have you developed? The motor program. So like this, there's some stairs on the top. They're just fixing all the stairs behind it used to be called the H building. Funny. All the stairs that are behind the F building up here that go up onto the fire road, those are like cray steep. Most people who go up them for the first time trip because the stairs are short and extremely steep. And because they're short and steep, it's a new motor program to learn. But once you've gone up them a couple hundred times, what happens? You get it. So that's primarily the reason why escalators, and the other thing about escalators, what do you notice about the visual feedback you get from the escalator feet? The lines go the wrong way. How do we see stairs? Perpendicular. What are the line references you get on an escalator? Vertical. They're going this way. So you can't see the edge very well because all the edges line up and our occipital lobe goes, ah. Yeah, and plus they're angry looking. Yeah, and I never really thought much about escalators until my daughter tripped. And every time I'm like, I'm wearing flops or something, and I go on an escalator, I'm like, oh, toes. Like, ah! I just, yeah. But for me, I always try to take the stairs if I can find stairs. It's not easy to find stairs. I like going up and down the stairs. Even when I had my knee surgery, I'm hobbling up the stairs. If you go to Kaiser, if you go to any of the hospitals, who do you always run into in the stairs? The doctors always take the stairs. Because the really sick people are in there going, yeah, take the damn stairs. Sick people don't take the stairs. Research study, germs on stairwell railings compared to germs in elevator railings. Okay. Yeah, just walk in a little bubble of hand sanitizer. Yeah. Or just wash your hands occasionally, which works well too. Okay, so yeah, a lot of British bands sound American when they sing. Yeah, and the reason is because different motor programs. So thank you for bringing me back to reality. Okay, no, but the idea, so when a stutter is, one of the theories on stuttering is that you're using the right side of your brain over here to produce language. So you think of what you want to say. So you're the right hemisphere of the brain, this side, right? The right hemisphere thinks in big pictures. The right hemisphere thinks in the main idea. Okay, the left hemisphere thinks in the actual words. So if you think in the details of the words, where do you think language is typically stored? On the left side, because that's the detail, that's the words. All your vocabulary is generally on your left side. The right side is the general meaning of it. So if you're trying to speak with the meaning of what you're saying, sometimes you can't find the words, so you get stuck on the syllables. That's one of the theories of stuttering. But the crazy thing is that for my daughter, all we did is reinforce her for talking smooth. So she would say something and not be bumpy, and we would say, wow, you said that very smoothly. Good job. We just reinforced her saying things smoothly. I talk fast. The reason I talk fast is probably the reason that she stuttered. My wife also talks extremely fast. So when my wife is talking fast and I'm talking fast, her baby brain's not as fast as ours, so why does she stutter? She's trying to speak as fast as we do, and so when we're training her to not stutter, we're also talking slowly, like Dora. And boots. Notebook. Okay. Lunchbox. I get all my kids' Castaway lunchboxes. Okay. I have a really cool Vera Wang one too, but anyway. So, I don't know where that is. I think I may have thrown it away because I left crap in it in the car for about a month. Yeah. Moving on. So, in your temporal lobe, there's one other part. I'm sorry that wasn't the greatest answer for your question, but the escalator is cool too. Get distracted there. Okay. The auditory cortex is right here. Okay, so the auditory cortex is a part of your brain where you hear sounds. Where you hear sound. So let me play you a quick little video clip of the auditory cortex. What does Bobby McFerrin understand? Music. And he goes, oh, everywhere I am, people understand that. He was able to make the audience sing the correct notes, even though he modeled the first 5 notes for them, because he can sing a pitch that everybody understands. And he purposely sang pitches that everybody understands. But then what did he do? He went off the stage, and people just got lower. Did they say the right sequence? That's how your auditory cortex hears. Your auditory cortex hears in sequence, in that pentatonic scale. Whole tone, half tone, whole tone, half tone. That's how your ears, well, not your ears, that's how your brain hears. I've had 2 students now with ocular implants. One of them actually, the 3 people I know, one of my neighbor's friend Oliver has a speaker on the top of his head and wires going into his brain. And that's how he hears. Because the auditory cortex is super simple. It hears that one scale. So how do you hear sound? Like I played Rammstein before class. How do you hear the sound? The vibrations in the air, activating little bones in your ears, the ears vibrating fluid, the fluid vibrating neurons, the neurons activating the different frequencies in your brain. One of my students named William, who has a little center, it goes into the back of his ear. And what it does is he's missing certain frequencies. The bones inside of his ear don't hear certain frequencies. They were funky when he was born. Another one of my students had the little bones in her ear. She got a really bad ear infection when she was little. And the infection got in the bones. And what happens when you get an infection in your bones? Hopefully that's never happened to anybody. But the bones fell apart. So she couldn't hear. So they inserted little plastic bones in there. Little 3D printed, I think it might be some sort of ceramic, but little bones in her ears, but she doesn't hear very well. So what she does is she could have gotten the ocular implants, but they went the route of manufacturing the bones. But she's missing certain frequencies. So what they do is they put the hearing aids in that adjust the frequencies. And what can she hear now? Sound. But first I had to learn the names of the colors you gave them. Once the brain figures it out, thank you, at least one person laughed at that. My kids still think it's funny. But as soon as he gets used to it, does he notice that the sounds are being generated from the electric speaker? No, they just become sounds. And he equates the sounds with behaviors, just like he did with driving the snake. Still, it's awesome. I sound like a raving lunatic, though, in the background of the video, so I got to fix that. But anyway, but it's so cool that the student that did it yesterday in class, he drove it around. He only got a score of 321, so you rocked it. But he was able to drive it around as well. The scanner wasn't working very well yesterday. I'm not sure exactly what's going on with it, but he was still able to drive the mouse around. He was able to rotate and push the cube. But what's crazy is that your auditory cortex is literally just frequencies. Just frequencies. Why do you think there's a huge other part of the auditory cortex? This is it. That's all. This is where you hear, right here. What's the rest of it for? This gets even weirder. This is where your thoughts are. Do people think in language? You say that so quickly. Well, I do. So you define yourself by yourself. Perfect! Welcome to psychology. So wait a second. Do you think in language? Rosa, are you thinking in English or Spanish right now? Can you think in Spanish? Yeah, when you're talking to someone fluently in Spanish, guess what happens? You think in Spanish. You have two languages in your head. You have two selves, man. You're not. Or better than the rest of us who only speak one language. Whatever. Okay. So what's interesting about your thoughts occur in your auditory cortex. Your thoughts are there. What are your thoughts for? Why do we have thoughts? Why do we have thoughts? Well, not to measure behavior. You're almost there. Something about behavior, because everything in this class is about behavior. So, I'll ask a question. Do you think this is a good idea if I throw it this way? There's actually people right in the front. Okay. Oh, dang it. I'm off a little bit. I got to get my state of yo. Okay. Obviously, you're not part of the Smothers Brothers clan. This is an original Tom Kuhn custom no-jive 3-in-1 special with 4 O's in smooth. It's that smooth. Okay. So this one, okay, but back in the old days, you have to get into a zen, a state of yo, in order to play with a yo-yo. Okay? State of yo. It's a zen kind of thing. This yo-yo does not come off the string. Or I guess it could, but I don't want to because it's old. And this is just a good old-fashioned, I got to get back in my state of yo here, wait. Okay. Okay, so, but when oh, come on now. I'm having trouble. I'm not doing too well with this one. No, not working very well. I need my good purple one in order to play with that one. Okay, but so the good, getting in a good state of yo means that you have to put your thoughts in a certain way. Once your thoughts are in a certain way, does it make your motor programs come out better? Yeah, there's a thing called Zen. Zen is the philosophy of doing something for the sake of doing it. You find the Zen in doing something, and once you find the Zen in it, you understand the principle and the thoughts behind doing it, it all becomes one. You become one with your behavior. It's awesome. One of my good friends named Brian taught me the Zen and the art of dishwashing. If you have to wash a lot of dishes, it sucks. But is there a Zen to washing dishes? Yes. You actually stop thinking that you're washing dishes and enjoy the fact that you're doing something that requires no intelligence whatsoever, except when if you're at an Italian restaurant like I did, you have to scrape cheese. That does require intelligence. But we made a cheese scraper. Using your thumbnail is gross. What do? No, metal scrubber scratches the plates. No, we actually found a piece of plastic that was shaped like a thumb. Works great. Because what's the easiest way to remove it off a plate? So take something that's not your thumb, because that's gross, because someone else didn't finish that cheese, and put the plastic thumb on your thumb and then scrape it off, and it worked perfectly. That's Brian's invention. He should patent that. Okay, do I have a good pocket here? Okay. Didn't get it first shot. Okay. Yeah, sort of. Hit the backboard though. I did that one semester, and it was too far in front of me, and I went, and I pulled my pocket right off my chair. So I've learned to lean into it. I don't know if you noticed that. So yeah. Okay, will it hit me in the face? Could, and I have hit myself in the face once or twice, just saying, but because I've done that enough times that I don't have to think about it. It doesn't require any thought to perform the behavior. There's no thought involved. It's just activating a motor program. What are your thoughts for then? Why have them? Yeah, to understand, to think about things, using thoughts and thinking. So your temporal lobe is paying attention to the language. Language and thoughts are the same thing. What you see, does that affect your thoughts? Yes, how you think affects how you learn and plan behavior. How you feel affects how you think. So this is why if I show you the crazy cyclist first, and then I ask you, were they doing something wrong even though the lady has a DUI? You look at them and go, yeah, they were. Because they were being stupid. No matter which order you saw the videos in on that experiment, with the crazy bicyclist, everybody thought once they watched the bicyclist zigzagging through traffic, they were stupid and that's why they got hit. Everybody scored 8 out of 10, it was a bicyclist at fault. Okay, but if you know that the lady has a DUI, does that affect whether the person's being stupid on their bike or not? No. They're still being stupid. It doesn't matter if the lady was drunk, they're riding upstream in city traffic. Okay, but if I say, before I show you that they're crazy, and I show you, oh, the lady's drunk, it's the woman's fault. So your thoughts, underneath the temporal lobe, and this is where we're going to get to next, underneath the temporal lobe are things called your limbic system. I'm going to make this brain a little smaller so I can write on it more. Because it's still pretty damn big on the screen up there. Okay, so just get perspective. Here, we're looking right now at this person right down the center of the brain. Good luck. Okay. So when you have to leave early, he just told me he had to leave early a while ago. I'll say good luck. If you have to leave early and you don't say something, I'll say something smart assy. Or, yeah, so he told me. I didn't say anything smart assy. Okay, so if you do have to leave, I don't care. Okay. Some teachers are like, well, My kids have taught me that I really don't matter, so it's okay. Okay. Be nice to your parents, kids. Okay. Watch out, that person's going to walk in front of you in the car. Well, they shouldn't. Yeah, they shouldn't have stepped in front of me. Okay, sorry. Yeah, next time, they'll learn. All right. Can we at least hose off the car? Okay. What's this part of the brain? That's the frontal lobe. What's on the top here? Motor cortex would be right here. Parietal lobe, good. What's back here? Occipital lobe. Can you see the temporal lobe from here? No, it's on the outside. So we're looking at the inside of the temporal lobe. So what's interesting is that some of the structures we're going to draw are actually in the temporal lobe, but I haven't quite figured out how to use 3D CAD with this software yet, so that would be even cooler if I could have a 3D brain that I could manipulate and move around. Stay tuned because I'm going to work on that. Okay, I've been trying it for like 20 years. Now I have a computer that can do it. Okay, so this part right here, which is not on the list, I'm going to color it in green, and then I'll switch off the green pen, called the corpus callosum. Maybe it is on the list. Nope, it's not on the list. Okay, the corpus callosum connects the left and right hemisphere together. All of you have an intact corpus callosum, unless you don't. That's stupid, but most people have an intact corpus callosum. Do people live in their left side or their right side? Or do they live in both? Both. Because this corpus callosum is there, it connects the two sides together. It is extremely well connected. Billions of neurons go back and forth across the corpus callosum. And as a result, your left and right sides communicate and talk to each other constantly. Only when we cut it in the split brain operation do we notice a difference. Yeah. Yeah, we don't, and males don't use language very well either. We don't dwell as much in the left hemisphere as we do in the right hemisphere. The problem with that research is don't say men or women, say masculine and feminine. And the reason is because it has nothing to do with your junk. It has a lot to do with your testosterone levels. Sorry, it's not appropriate. Now, no, but it's not your it's not your maleness or femaleness. It's your masculinity or femininity. People that are more feminine show more hemispheric crosses. People who are more masculine show less hemispheric crossing. A lot of times when you get the hypermasculine males and hypermasculine females, there's one answer to the problem. Answer. What about this? No. What up? No. Answer. Done. Okay? But so when we look at that, the way that the corpus callosum is connected has a lot to do with prenatal growth. And prenatal growth is affected by hormones and lots of other things. So that's a physio question well beyond this class, but it's pretty interesting, yeah. Connecting the left and right side. So in the center of the classroom, we would have the corpus callosum. So the left side and the right side are constantly talking to each other through the corpus callosum. So the right side of the class says, oh, I see the big picture. I understand the meaning of everything. These guys have all the details and the specifics and the tastes and the smells and the colors. You guys have the big idea. So if I show you a picture of a tree, what do you guys see? A tree. You guys see the leaves, the bark, the wind moving. You see all the details of that tree. You might not recognize it as a tree because you're hyper-focused on the details of it. You guys say, tree. And if you like trees, you say, good. If you don't like trees, you say, ew, burn it. Who doesn't like trees? I mean, really, hug them. Okay, sorry. So the reason why I have to bring this up is because even though we keep talking about this part does this part does that, is everything in your brain connected? No, all the time. All the time. If a part becomes disconnected, your brain stops feeding it and it will die. That's what happens after a stroke. Right after a stroke, the person's brain is pretty fine. Depending on, I mean, if it's a really bad stroke, it's bad. But right afterwards, they can actually recover very, very well. But what if they don't get any therapy or don't get any help right afterwards? If the part that the stroke killed died, then all the parts downstream start dying. And if someone is just sitting there in a nursing home just staring at the wall all day and not being stimulated, not being talked to, not all just watching daytime TV, their brain slowly gets smaller and smaller and smaller. Because anything downstream from the stroke. My neighbor had a massive stroke. Her name was MC. She recently passed away. But she was doing language therapy. She lost part of her left temporal lobe. So she lost her language. She couldn't talk. She could still make sounds with her mouth, but she couldn't form language. So what happened was she did speech therapy every single day. And she got her vocabulary coming back. She could actually read again. And her friend went on a cruise. When she came back from the cruise, she had lost all of her language again. Because was she practicing all the things that she should have been practicing? No, it's the same thing as if I lift a lot, I get all strong and muscly, and then I completely lay around all summer. Get all gooey again by the end of the summer. Good times. Okay, same thing. Okay, so I want to talk about this next, the rest of this part of the brain, I call the lower brain, are your emotions. So I want to label the emotional parts here. Okay, the emotional parts. Your hypothalamus is your hormones. Do your hormones affect emotions? Oh, the women say, yeah. The guy's like, no. Well, if some women are sensitive during their menstrual cycle, when they're ovulating, their behavior changes. They become friendly and nice, and then when they're not ovulating, they become cranky. Well, some women are much more affected by their cycles than other women. So if you stereotype and say, oh, women are cranky during their period, no, some women are. But if I'm thirsty, what happens? Does that change my behavior? Yeah, I start looking around at all the things that people have to drink. If I'm hungry, you start noticing food. And that's your hypothalamus. Your hypothalamus is sitting right deep down inside your brain. We'll color it this nice red color. It's right here. This little thing hanging from it's called your pituitary gland. Kind of important for your body. The pituitary gland is what causes your body's hormones to be released. So your hypothalamus, let me put your little eyeball here. Let's say you see someone that you're attracted to standing upside down. That's weird. Okay. Hello. I'm going to put a little baseball hat on this person. Hey, sexy. Kind of looks like a conquistador with that hat on, but that's okay. Oh, geez, that's awkward. I didn't see it down in my computer. Let's get rid of that, because that's just weird. Okay, so we have this person that you're attracted to. If you're attracted to someone, there's a part of your hypothalamus that goes, it's called the lateral preoptic area. It goes, pay attention to that. So you're scanning a crowd of people, and you see someone you're attracted to, and your brain goes, wait on that one. What does it do to your motor program? It stops and makes you focus on something. That's one of the things that your hormones do. Hormones in humans are not nearly as powerful as hormones in animals. If there's a female dog in heat, if she's emitting estrous hormones, okay, and if anybody's ever had a female dog in heat, they emit a lot of hormones. Even humans can smell them. You walk by, oh, it stinks. The dog's like on the back of the couch. Oh, every male dog in the planet is done what? Yeah, even if it can't get to the dog, it's like on the fence. And you're like, that's why in some cultures dogs are the lowest form of animal, because they just act on their hormones. If the dog's hungry, it's like, I'll eat that. If it has extra testosterone, it'll start humping things. Our neighbor's dachshund, Otto, would have romance with his blanket every night. He'd be out there, it's like, dude! He's like looking at you like, what? You need to get that thing fixed, so he stops. When you get them fixed, what happens? They stop. Well, depending on how old they are. If they're young and you get them fixed, they stop. But if they're old, they're like, I still know how to do it. And they, yeah. Sorry for being male. Okay, now. But this thing about the hypothalamus is, does it cause human behavior? It influences human behavior. So if I inject testosterone into everybody, guess what happens to mating behavior? It increases the probability of mating behavior. That's what, and it's interesting because that if I increase, there's a hormone called aldosterone that's released. If I introduce aldosterone to your brain, it makes you thirsty. Because that's the hormone that is produced that makes you feel, now I'm talking about drinking water. Okay? So the object is that the hypothalamus influences. It doesn't cause, it influences. Okay? The thalamus. This is really hard to conceptually understand. Your thalamus is a sensory relay. All of your senses, including smell, pass through the thalamus. Smell is unique. Smell goes to your cortex first, as. Because it's because as you are seeing things, what's happening? What is the thalamus doing? Relaying the information to your occipital lobe. It's also sending it to other parts of your brain, which we'll talk about in a minute. So as you are seeing something, your brain is doing two things at once. You're seeing it, and then you start feeling emotions to it. For example, there's this part of your brain called the nucleus accumbens. I'm going to write the word dopamine here. The nucleus accumbens, let me draw that on here. We'll draw it in pink. Where is it right next to? Right by the hypothalamus. There's a lot of nuclei, a lot of neurons that connect the hypothalamus to the nucleus accumbens. Does water taste better when you're thirsty? Wow. It's more satisfying when you're thirsty. So if the hormone need is there, all of a sudden, the nucleus accumbens says, ah. The nucleus accumbens is the satisfaction part of your brain. It produces satisfaction. So drugs like amphetamine and cocaine, guess what they stimulate? The nucleus accumbens. Yeah. Serotonin is a calming. So you feel not satisfied, but you feel relaxed with serotonin. So it's a difference, because if I give you serotonin, a drug that stimulates serotonin, it causes diarrhea, abdominal distress, and hallucination. But if I give you a drug that produces dopamine in the brain, you feel satisfied. So like, for example, an M&M is a very well-engineered candy. Because what it is, it gives you a crunch and then an immediate shot of chocolate, which releases dopamine, followed by a really pleasant aftertaste. So the cool thing is M&Ms are very addictive because the initial crunch releases dopamine. Crunch. You could have eaten the entire giant bag and lying there on the couch feeling bad about yourself, and you look down and there's one more in your belly button. Even though you're feeling, you obviously eat M&Ms without your shirt on. Now, everybody else does. Okay, so, but if you're lying there, even if you feel sick to your stomach, careful, third step, okay. Even if you feel sick to your stomach, is that last M&M super satisfying? Yes, you got a phone call. Okay. It's still just as satisfying as that first M&M you ate, even though you still feel sick, because that initial crunch produces dopamine in the nucleus accumbens. That's why they're so freaking addictive, okay? Especially the peanut ones. Okay. You eat a whole bag, it's like 400 calories. Like, seriously? Okay. So, the amygdala. The amygdala is exactly the opposite of the nucleus accumbens. What would be the opposite of feeling good? It's anxiety and fear. The amygdala, anxiety and fear, it sits right here. But I want you to think about the amygdala as on the outside. Not on the inside, but on the outside, because it's in the temporal lobe. It's in the temporal lobe. And it's constantly saying, oh shit. Because this is really important. It's the easiest way to remember it, because your amygdala is the one that makes you startle. It activates the basic fight or flight motor program. Humans, for some reason, when you startle them, they all look the same. Okay, you can look at startle videos. I don't like prank things, but look at, there's some guy who has a loud horn on his truck and he drives by and honks at people and videotapes it on Instagram. So, and I've watched them, so it's worked. Anyway, but you drive up and go, eh. What do people do when you, eh? You do this. You brace, your hands come up and your head goes down. Why would you brace? To protect yourself. And maybe it's from an arboreal self where we evolved in trees, then any sort of loud sound would cause us to spread your hands out. Why would your hands go open? Third step. So why would your hands go out? To be ready to grab something. And why would you brace? So if you're ever about mountain biking and you're about to crash, well, yeah, wear your helmet. I don't pick my head. Make a fist when you crash. What causes your wrist to break? Yeah, so do what you just did. Yeah, so what happens is if your hands are loose, you're going to hit something and it'll pop and it can break your wrist. But if you clench your fists, one of the things you'd say, punch the ground. Don't really punch it, but just put your hands together, clench your fists. When you clench your fist, it strengthens the whole joint. You're less likely to break your wrist. And if you do, you're going to break it anyway, so it's forever. But the same thing is that if you brace right before an impact, you're less likely to get hurt. Just have your kid punch you sometime. My son does all the time. And sometimes he's punching me in the back. I'm like, ugh. So I go, punk, and he's like, ow. I'm like, car crash. Yeah. So a car crash is different than falling off a bicycle or falling out of a tree. What do you have? Well, the drunk drivers that survive better are generally the ones wearing the seatbelt. See the difference? And with airbags. And if you're drunk, if you brace yourself in a car crash, what is likely to happen? If you're squeezing the steering wheel really hard and the airbag hits, hopefully no one's had an airbag go off in their face before, what can that do? Blows your hands away. My daughter likes to sit with her feet up on the dashboard. Every time she gets in the car, I'm like, put your damn feet down. No, it's comfortable. Yeah, until the airbag goes off and your shins are in your forehead. Well, we watched the real stories of the ER, and yeah. Sorry. Okay, so in a low-speed impact, bracing is good. Just try to go floppy sometime playing football. What happens? You get much more injured than if you brace before you hit somebody. But, okay. So it's a natural response for you to stiffen up. But that's your amygdala. Your amygdala directly connects, running out of time, directly connects to this part of the brain down here called the medulla. Don't know why I just wrote it. It's right there. That's just a cue. Shh. The way I remember this is your medulla is your autopilot. The medulla is the part of your brain that controls respiration, breathing. I just said the same thing twice. Man, I'm struggling. Okay, it controls your heart rate. It controls your sweating. It's your autopilot. It's the stuff that you don't have to sit and think about. So if I get scared, what happens to my autopilot? Everything speeds up. Everything speeds up. And as soon as I'm not scared anymore, my autopilot relaxes. Yes. Autonomic. You're the official spokesperson of what the hell does that say, which I respect. So it's autonomic, which means it happens without you being conscious of. It happens automatically. So I like the word autopilot is how I remember autonomic. Okay, so there's one more part that's really important called the cerebellum. I mean, the pons is important, but the cerebellum is the timing. How do you know how to activate the motor program? How do I know when to activate the motor program? This one's a little sketchier than the other one. I gotta bring my good one in. Okay. So this one is a combination of the other two. This one's actually not too bad as a yo-yo. So with this one, how do I know when to activate a particular motor program? It's timing. So I take my visual systems, I take my thought process, I take my auditory sensation, because you can hear the bearing and when it's going to come back up, and that all goes down to my motor programs, which activates the cerebellum, which coordinates it all together. All right, what do you need for next week, next Wednesday? The pons is sleep and consciousness. It's in the book, you can find it. What do you need for next Wednesday? Know everything, but bring all the stuff that we have done. Bring it, yeah, bring it, because you can use it on the assessment, and I want to collect if you turn it in.